Hey guys, we're here with Bill from Polkadot. He'll be doing a intro to Polkadot for DeFi. Can you guys confirm that you can hear him once he starts talking?
Hi, everyone. Can you hear me? Yes, no? Okay. So my name is Bill Laboon. I'm the technical education lead here at the Web3 Foundation in Switzerland. Thank you for the confirmations, everyone. So today I'm going to discuss Polkadot. And this talk is really going to have, I think, two parts. The first is sort of the foundation, the fundamentals of what Polkadot is. And I then want to discuss why it specifically is good, could be good for DeFi or the particular projects that you're working on. So some of the benefits and drawbacks of it. So let's start the show. All right. So from a very high level, you can think of Polkadot as really two parts. Really what differentiates it from other blockchains is this sort of multi-level aspect to it. So there's a relay chain. So this is the fundamental chain of Polkadot. When people talk about Polkadot, usually this is what about a chain on Polkadot, this is what they mean. It is a single fundamental connector chain that has strong economic security and a protocol for interoperability. And there are these parachains or parathreads, and I'll talk about the difference between them in a moment, that are where the more user-facing activity takes place. And these parachains can be more specific to individual features that a particular blockchain would want to have. So the relay chain, as I mentioned, is a very simple chain, and its focus is on coordinating the parachains. So these parachains, again, are different blockchains, and I'll talk about what and how they work in a moment. The relay chain is a nominated proof of stake chain, and it has an interesting hybrid consensus model. Again, I don't want to get too deep into the weeds here in terms of consensus, but one of the interesting things is that the block production mechanism is separate from its finalization mechanism, so that we can have blocks being produced as well as a finalization mechanism that provides provable finality of information that's stored on the relay chain. And these parachains are parallelizable blockchains. So this is what makes Polkadot really a network as opposed to a single blockchain. You may have also heard this concept referred to as shards. So these parachains are basically shards, but they're heterogeneous, which I'll talk about in a moment. Basically, they can be different. There are also this concept of parathreads, which are merely parachains that don't always stay connected to the relay chain. If you're a software developer, you're probably familiar with threads. They just interact with the processor when they need to. And so if you are interested in building a blockchain or interacting with these blockchains, these parachains, you can have two different levels. So you may have a blockchain, a parachain, which needs to be connected to the relay chain at all times, or you may have a chain that only needs to interact occasionally with it. You're generally independent, but you occasionally want to interact with other systems. So you've probably heard of other systems producing sharded blockchains, but Polkadot is different in that the shards are heterogeneous. So every parachain has its own runtime logic. That is, unlike some systems where you may have 1,000 copies of the same basic blockchain that makes the same trade-offs, with Polkadot, you can develop parachains that have their own unique trade-offs, that have their own unique features, their own unique capabilities, and of course, as with all blockchains, their own unique drawbacks. An interesting thing about this concept is that because these parachains are heterogeneous and we can write the code for them ourselves and determine what the runtime activity is like, they can also act as virtual external blockchains. So we can have bridges to other blockchains out there. And then from the system's perspective, they act just like virtual parachains. And since parachains can communicate with each other and actually determine ahead of time how those messages that are sent or can be interpreted, then we also can interact with these external blockchains. So we are providing really a system that eliminates the silos between blockchains, that we can have all of these different blockchains. People can develop their own chains. They're going to have their own trade-offs, but they can all exist under the same security guarantees of the relay chain. So heterogeneous shards, I think, is sort of a complicated concept to get at first. So I think the best thing I can do is just walk through an example of what is possible with this. So before I get too deep into this, I want to explain pallets. So the framework that is used to create these parachains, so we have a framework that I'll discuss briefly in a moment that allows individuals and teams to make their own parachains, has these items called pallets, which you can think of as, if you're a software developer, as libraries or modules, the ability to add functionality into the blockchain in a plug-and-play sort of manner. So we can decide what kind of features we want on the blockchain that we're producing, and then add these pallets. So you can produce your own pallets. There's basically a development kit that you can make your own, or you can include some of the ones that are that we have already produced, or that Parity, who is writing the initial implementation of Polkadot, have produced. So there are currently 42 pallets. And I'll show some of these as examples in the parachains that I'll discuss now. So here we have Avocado supply chain. So this is a chain that was developed by some avocado producers. And while they may not trust each other individually, they do trust each other as a whole. They trust that there will be anyone who has joined this group of avocado suppliers, at least 50% of them will be honest. And so as we're developing a chain to try to monitor our avocado supply chain, we add a few pallets to this. So the first is ARA, which is our proof of authority consensus mechanism. So that is, we indicate that there are certain people that we trust to produce blocks and determine the which transactions are going to be included and their validity. We're going to have the sudo palette, which allows super user powers by authority, such as the ability to add others to that proof of authority consensus network. We'll have an identity palette. So this is going to provide identities to people. We can have registrars which can identify people and maintain on-chain identities after access has been granted. And we may have written our own built-in supply chain management palette that actually controls and has individual storage features regarding avocados, like their level of ripeness and what city they came from, etc. So now let's imagine a different chain. So as a cypherpunk, I want to hang out with other cypherpunks. But I probably don't want a lot of the same features that we would find in that avocado supply chain management. I certainly don't want sudo. I don't want to have individuals that have power over the entire network. I probably don't want identity. I want to maintain my secrecy. Right? So I'll add to my blockchain proof of stake palettes that allow for staking and consensus. I'll add a society palette, which allows groups to form on-chain memberships and prove on-chain that someone belongs or doesn't belong to a group. Democracy, I'll provide a governance system so that stakeholders can vote on upgrades and modifications to the chain. I may add the EVM palette, which is an implementation of the Ethereum virtual machine, so I can run smart contracts. I may write my own privacy palettes here. So we can see here two very different chains that have very different uses, and very different trade-offs were made in terms of the features added and what you get by using the chain. But you may decide that you want something that's a hybrid between the two. You may want some of the features from one chain or another. So you could certainly produce your own chain as well by selecting which pallets you want and maybe even writing your own or getting rid of some that exist that you don't want and making your own chain. But no matter what one of these chains you produce, or if you're using a blockchain that is external to the system but is bridged in, you can still communicate. You can still send messages from one parachain to another through the relay chain. You are sharing in the security behind this. Any of the parachains that are connected to the relay chain share in the security of the system as a whole. But through this, we're reducing silos. So let's say that our Cypherpunk Hangout chain develops a really interesting smart contract, and our Avocado supply chain people want to use that contract, but they want to use it in order to ensure their avocados. Well, they can call into that chain, make messages to it, and call smart contracts on that chain that have impact on the chain that it's called from. If we want to bridge out, so we want to make sure that your avocado suppliers have a decent supply of Bitcoin, as a bond, then we can call out to the Bitcoin blockchain and ensure that they have so many Bitcoin. So by making the ability to create all of these different chains, we get a lot of the benefits of making these trade-offs. But because they're all interconnected and interoperable, then we also have the benefits of these other chains that can exist and what people are making on them. So how do I do that? I just sort of hand waved about adding these pallets. So one of the interesting things about these parachains, as well as the relay chain, all of these systems are built on something called the Polkadot Host, which is like a very small virtual machine. And it runs WebAssembly, WASM, bytecode to indicate the transition functions of the blocks, to say what are the rules for this blockchain, basically. So the Polkadot host is relatively small, but it handles a lot of the boring backend stuff that isn't directly relevant to the rules of the blockchain. For example, storing data in the database, or like the peer-to-peer, developing the peer-to-peer network, etc. You, as a blockchain developer or parachain developer, can simply focus on writing the WebAssembly blob that is going to indicate the state transition function or the rules of your runtime, and run it. So another interesting thing about this is because everything is just a WASM bytecode, this can also be sent out over the network. So we actually can upgrade the system and change the rules of it without implementing a fork. We can send the bytecode out over the network. It gets propagated to all the nodes, and then they continue running with this new version of the bytecode. And this also means that there's no off-chain coordination every time there's an update to the software. Rather, the code just is sent out over the network, and at some point at the particular block that it's supposed to start running at, this new code actually runs. So it's kind of like thinking back like when the JVM, a virtual machine started, right? That instead of sending out a new JVM each time you wanted to run new code, you could just send out new code and run it on top of it. The framework that we have for developing these parachains is called Substrate. And right now it's written in Rust, and it lets you add these modules or remove them or write your own according to our development framework as a sort of Lego system. So people refer to DeFi as money Legos. You can build interesting things by combining them in different ways. With Substrate, you can build interesting blockchains by adding and subtracting different features, or even making your own Legos and adding them on to your system. So when you're developing one of these parachains, and you may have been thinking this question while you saw my example of the Avocado suppliers and the cypherpunks, what are the benefits of writing your own runtime? Why can't I just write a smart contract to do all this stuff? What is the benefit of actually making my own chain for this? And so the first is really control. So if you have an idea of a different cryptographic primitives you want to use, or a different kind of virtual machine for your smart contracts, or very specific rules on access to the chain, then this is something you can do at the runtime, but you're really kind of limited in doing at the smart contract level. Smart contracts don't really let you dive quite as deeply. And flexibility. So with the ability to modify all of the WASM, you can update your software, you can modify the chain, and you can do it in all sorts of different languages as long as you can compile them down to WebAssembly. So C++ or Rust or C, assembly script. There are a lot of different things you can do here. You have a lot more choices because you have a lot more control all the way down to the fundamental rules of the blockchain. You can sort of break out of whatever virtual machine is on the that is interpreting your contract code. Scalability. So because it is a sharded system, there's much less concern about others clogging your system, right? So if you have a DeFi-focused chain, and the only people that are accessing it are those that are using your DeFi services, then you don't have to worry about there being some new Ponzi scheme or some other network clogging event. You have a lot more control over the prioritization of the messages and what can take place on your particular chain. But of course, you don't have to. So if your particular capabilities and functionality doesn't require building a runtime from scratch, which again is because it's much more flexible, that also means there's more room for problems. You can write a smart contract on top of one of the chains that others have built. So there are already several smart contract chains that are being built on Polkadot. And just like you can build on top of other chains, other external smart contract chains, you can build on these Polkadot smart contract chains and have the added capabilities, if those chains let you, of interacting with the other parachains as well. So again, this is a very high level overview of what Polkadot is, and the specifics of it would probably have to, we would probably be here for quite a while talking. But I wanted to specify, why is Polkadot suited for DeFi? So hopefully you already got some ideas from hearing what is Polkadot capable of doing. But I wanted to discuss briefly some of the specifics. So first is that cross-chain communication is built into the protocol. So interacting from one parachain to another is automatically built in if you want to use it. But it's not just for token ownership. So I realize there are wrapped Bitcoin on several networks and other token ownership from one network to another. But the interesting thing about parachains is that in this cross-chain communication protocol that we have is that allows arbitrary data to be sent. So what this means is you could have things other than just ownership transferred. And you may be able to do this across multiple chains. So let's imagine we have an IoT chain, an Internet of Things chain, and one of the kinds of items that are on this chain are weather sensors. And these weather sensors can then be queried by some other chain that acts as an oracle chain that provides average weather in a particular area. And some other chain that offers insurance based on weather and perhaps pays out in Bitcoin if you're a farmer and you want insurance in case the weather drops below whatever 20 degrees in the month of June, then the IoT devices can send this data to the Oracle chain, which sends it to an insurance chain, which can automatically release Bitcoin and send it to somebody. So we can see that being able to send just arbitrary data, as well as being able to actually prove how the receiving chain is going to interpret that data. So we don't just send a blob of bytes and hope that they'll do something with it. We actually can prove that we sent it, prove that we received it, and we can check ahead of time how it's going to be decoded and interpreted by the receiving chain. And all of this comes built in when you develop a parachain. Just by virtue of it being able to interact with the relay chain, it's also able to do all of this other interesting data transfer. And I think that has there are a lot of possibilities there for this, like cross-chain communication and doing interesting things other than just owning tokens of one kind or another. So a second thing is that on the relay chain, we have provable finality. So I remember the first time I ever gave a talk about Bitcoin to a group of accountants, and I started explaining probabilistic finality. That yes, there's always a chance that a few blocks we went down the wrong fork and there's a longer chain with proof of work, and the odds are astronomical that it will do that, but it's still it's always a very remote possibility. And they were. You could see they were very a few people were very upset. Like, well, how can you even say it's final if you can't prove it, if it's not deterministic, if it's not set in stone? I thought a blockchain was supposed to be immutable. And so this, I think, is a good way of explaining, perhaps, or showing a more final finality, if you will, because we actually, with our finality gadget, can prove finality on the relay chain. After there's a 2/3 vote, then that block will be immutable. There's no way around removing it. But one of the problems, of course, of provable finality is that if you don't have the required number of nodes to come to a consensus, then you actually will not be able to move forward. So remember, I mentioned we had hybrid consensus. So our system actually has a fallback. So in case the finality gadget cannot come to finality for some reason, such as major network partitioning, we'll actually keep producing blocks until we won't stall. We'll actually keep producing blocks until finality can catch up. So once a new what we call a new era comes in, and new validators get voted in, and we once again can finalize, then we actually can provably finalize no matter how long we've had that network partition that caused us not to be able to avoid it. So finally, another interesting thing is that we can really use any language that compiles down to WASM. So Rust is what we have been mostly been using now, but there are several projects out there working on developing the ability to make your own runtimes or smart contracts in different languages, such as assembly script, or you can write your own. As long as your code can compile down to WebAssembly, and there are numerous programming languages that WebAssembly supports, then you can use that. Right, so you're not limited to any specific language. If you don't have to learn a specific language to write smart contracts on Polkadot, as long as you can compile down to WASM, you'll be able to make a runtime or a smart contract. So that was my introduction to Polkadot, and specifically for DeFi. Excuse me, I'll take some questions now, but if you want to reach out to me, feel free. I'm at Bill Laboon on Twitter, or bill@web3.foundation, or you can go to polkadot.network or web3.foundation. So I'm going to answer some of the questions here. All right, so let's see who has the highest votes. Okay, what are the benefits and advantages of the Polkadot network over Ethereum or Cosmos? So I would say that there are some real differences that we could get into. But I would say from a very high level, Ethereum is sharded, but it does, it's homogeneous shards. You really can't build the runtime, right? You can't have these like individualized shards that are going to that can have specific needs and purposes. On the other hand, though, obviously, Ethereum has a much deeper and longer development ecosystem. Cosmos, with their IBC, their inter-blockchain protocol, that is sort of similar, except they don't have shared security. So the networks there really are independent, as opposed to being part of, when you're part of the relay chain, you really, all the parachains are sharing in security. It's more of in that sense, it's more of a homogeneous system. But like I said, there are more details. If you go to wiki.polkadot.network, you can see we have comparisons for Ethereum, Cosmos, Dfinity, and quite a few others if you're interested in seeing the differences between different networks. So what is the main difference between ETH, ADA, so that's Cardano, EOS, Tron, and Polkadot? Okay, so I've already mentioned kind of Ether. Cardano also is homogeneous. They also really, with their Haskell approach, they have really good. Cardano is a great system. They have a much more formal methods approach. Their sharding mechanism is also a little bit different from us. EOS. So they have, one of our goals really is to avoid some of the things that have plagued EOS, like we're getting a large number of validators. On the relay chain, we really do not want any sort of like cabals to form. So the eventual goal is to have 1,000 validators on the relay chain, which is why actually we have a project or a program called 1,000 Validators, which is meant to bring people up to that. If you're interested in running a validator, but you don't perhaps have don't think you have the technical skills or the amount of Kusama or dots to stake in order to get that, will actually help you. I'm not that familiar with Tron off the top of my head, so I don't want to say anything that I'm not sure about that. I'd have to look into it. All right. How are fees determined on each chain, and how do you handle DOS attacks, the denial of service attacks? Sorry, things are moving around here. So it's actually up to you as the developer of the chain how fees are going to work on that chain. So there is a fee in DOTS in order to join the relay chain and stay connected to it. But you can have a chain that is that develops tokens via proof of work. You can have inflationary chain or a deflationary chain, a static chain. That's really at the runtime level, which means that you can decide how that works. If you want to experiment with a gasless smart contract chain or something strange like that, then you can do that. In terms of denial of service attacks, so the fact that we are distributed, there's no real choke points. So there are individual nodes that obviously if you found out where that node is, you could attack them. Although we recommend when running a validator, where that's very important, you set up sentry nodes. So you have other nodes that are sort of acting as relay nodes. So we also, when these parachains are trying to interact with the relay chain or vice versa, it's actually done via an erasure coding scheme. So like lots and lots of bits are sent out, lots of chunks of the code, which can be reproduced by the other end of the system. And so we really try to avoid there ever being any choke point. Now that being said, we know there are some possible attacks, and there are some that we are working on mitigating. but that's, we really have done a good job of, I think, of really decentralizing everything and making sure that there is no one particular point that really would be victim to a DOS. Now, again, obviously, a single node could be if people know where it is, but there's the system as a whole is pretty resilient. Cross-chain means only between the parachains in this context. So yes, here cross-chain means between parachains, but remember that an external blockchain can be bridged to a parachain. So it acts as basically a virtual a virtual parachain. So from the system's perspective, it's as though Ethereum or Bitcoin or Zcash or whatever, it's acting like a parachain. And so there can be communication between those networks, at least up to the level of what that network is capable of, right? So I can't send arbitrary messages to Bitcoin, for instance, because it only understands certain transactions. It doesn't understand just any bit of data. With cross-chain arbitrary data, can you have something like verified cross-chain smart contract execution? So I think, you'll be able to tell, right? So yeah, if you have the smart contract using Spree, you can tell how that information is going to be interpreted and whether or not it's been correct, at least according to the rules of that chain. Now, obviously, you won't be able to verify something that's off-chain, right? In Oracle, there's no way, it would be magic, right, to be able to verify that something coming off-chain is correct according to the rules of that chain. I think it's 9. That I think ends. Again, if you have any more questions, please feel free to reach out to me, Bill at web3.foundation.
Awesome. Thank you so much for the really great talk. We're going to switch to our next session now.